When integrating functions that contain logarithms, you usually want to think about doing a reverse chain integration, where u would equal ln x, or something that contains that natural log, and u prime would be 1 over x or something similar to that. So let's do some examples. I'm going to try making u equal to natural log of x, and the derivative of u with respect to x is equal to 1 over x. I'm going to solve for du by multiplying both sides by dx. So this integral, I could actually rewrite it just for the visual sake as natural log of x times 1 over x dx. And hopefully you can see that this will be u and this will be du. So u is equal to natural log of x, and then 1 over x times dx is equal to du. So if we're taking the integral of some function of x to the power of 1, then we will just add 1 to that exponent. So 1 plus 1, which is 2, and this is over 2, plus c. They asked us to integrate with respect to x though, so let's substitute. U is equal to natural log of x squared over 2 plus c. This time I have a quantity that involves a natural log, so I'm going to first try making that entire quantity our u and see if that works. This would make du dx equal to 0 minus the derivative of natural log x is just 1 over x. So we have du over dx is negative 1 over x. And in solving for du, I get negative 1 over x dx. I'm going to rewrite this fraction so that we can visually see what we're doing. We have 1 over the quantity 2 minus natural log x cubed times 1 over x dx. This is just another way of writing it. I almost have it, but there's this little negative right here. So we're going to have to multiply this integral by a special form of the number 1, negative 1 times negative 1. Okay, and then I moved the negative so that it looks exactly like the du that we have to make it visually easy to see the transition when we substitute u. So 1 over u cubed du. And now this is a lot easier to integrate. This will be negative 1. This can be rewritten as u to the negative 3. And to integrate that, we add 1 to the power. That also is the denominator. They asked us to integrate with respect to x, and so I need to substitute the x back in, but before I do that, I'm going to simplify this piece right here. Negative over a negative is a positive, and this u to the negative 2 should be in the denominator. So now we have a positive 1 over 2 u squared plus c, and then replace the u with 2 minus natural log of x. This one's a little different. Remember that when we would integrate some fraction with a radical, then u was usually equal to the radicand. But that was when you could write the entire quantity, like an entire numerator or the entire denominator, as a power. As in this case, we could write this as x minus 1 to the 1/2. But here we just have x to the 1/2 minus 1. The entire denominator cannot be written as a power. Going off that method, u would just equal x, and that would not change really what we're integrating. It would literally be the same thing, and we'd be stuck again. So u cannot equal x. But what if u is equal to square root x? So after rewriting that as a power, du dx is 1/2 x to the negative 1/2, which simplifies to be 1 over 2 square root x. And then to get du by itself, I'll multiply both sides by dx. But there's a problem because dx comes attached to this 1 over 2 root x, and 1 over 2 root x is not in our integrand. All I have is a dx. So what if I try to get dx by itself? That would make dx equal to 2 root x times du. Ooh, we do not want an x and a u in the same expression here, but we actually have a way of rewriting square root x in terms of u because u is square root x. So instead of dx equals 2 root x times du, it's actually going to be 2u du. That is what dx is equal to. After doing this, I think we can turn this entire integral in terms of u. I'm going to take the 2 out of the integrand, so I have 2 times the integral of u over u minus 1 du, and now it's time to integrate. Wait, I can't integrate this. But remember, we learned a rule earlier that if the degree of the numerator is greater than or equal to the degree of the denominator, then we need to do some long division in order to split this up, and then it'll be much easier to integrate. So I'm dividing the numerator by the denominator. This could be written as u plus 0 if we want to take into account that column. So u goes into u only one time, and we'll put that in the numbers column. 1 times u minus 1 is u minus 1. And then we draw our line and change our signs, and we get 1. 1 is our remainder, and we write the remainder over the divisor. So we have 2 times the integral of u over u minus 1. And u over u minus 1 can be rewritten as this expression with 2 terms. So now I'm going to take 2 times the integral of this expression. And I can actually separate that and take the integral of each of those pieces separately. So I'm integrating 1 with respect to du, and I'm integrating 1 over u minus 1 with respect to u. 2 times the integral of 1 is u plus, so what I did was write v is equal to u minus 1 because we're already using u, so I'm going to use v instead. V prime is equal to 1. Okay, so v prime is present. Right here, it looks like we have v prime over v is what you are integrating. That is just the natural log of whatever v is. And don't forget that you need to have the absolute value of u minus 1 plus c. They asked us to integrate with respect to x, so substitute u equals square root x for the final answer. And there it is.